Good morning. So today we're going to talk a little bit about types of symmetry and how you can find that symmetry to graph. But for this homework, we're not going to do the graphing part of the homework. We're just going to talk about the symmetry. So you don't have to worry about half of it, and I'll tell you that at the very end. So the types of symmetry that you can have is you can have symmetrical to the pi over 2 here. So almost as similar as being symmetrical across the y-axis. So that means that the left side looks identical to the right side. Okay. It could also be symmetrical to the polar axis. So it just means that everything is in line with this polar axis here. And then symmetrical across the pole. So here is your pole. Then it would be symmetrical on either side of the pole. Okay, symmetrical across a polar axis would just be that maybe it's it's symmetrical across one of these poles. Okay, all right. So how you can determine these polar types of symmetries are that if it is symmetrical to pi over 2. So if it's going to be symmetrical to pi over 2, then you are going to replace so you're going to replace the r over theta with negative r negative theta, or r and pi minus theta. Okay. So if you replace it, then it's going to yield the same equation. Okay. So if it replaces it and you get that exact same equation, then it's going to have that type of symmetry. All right, so if it's a polar axis, you are going to replace your r theta, but you're going to replace it with r negative theta, or negative r and pi minus theta. And then if it's symmetrical about the pole, you're going to replace your r theta. You're going to replace it with negative r positive theta, or r pi plus a theta. Okay, so when you replace in the equation I'll say this, if it produces the same equation it passes the symmetry test. So if you wanted to say that it was symmetrical across pi over 2, when you replace in your equation your r and theta with a negative r and a negative theta, it should give you the same equation. Okay, if it gives you the same equation, then it's going to pass the symmetry test here. So it's going to be symmetrical across pi over 2. If it doesn't, then we're going to go to polar axes here. Okay, so for polar, we're still going to replace your r and theta with r negative theta. If it gives you the same equation, then it passes that, so it's going to be symmetrical across a polar axis. If it's a pole, same thing, you're going to replace with this, and if it gives you the same equation, then it passes the test. Okay, so let's look at some, let's see And this is all I want you to do for this homework here. So for homework 2, all I want you to do is determine the symmetry. Okay, so determine the type of symmetry. So is the type of symmetry theta pi over 2? Okay, so what am I going to do? I'm going to replace my r with negative r, and I'm going to replace my cosine theta with a negative theta. So I'm going to have negative r. 2 cosine is an even function, so that means that this is still going to be 2 cosine of theta, right? If I divide everything by this negative here, then I'm going to get r equals a negative 2 minus 2 cosine of theta. So that is not the same exact equation, so this is not going to be symmetry at pi over 2. Okay? Alright, so let's look at polar. So polar, what am I going to do for polar? I'm going to replace the theta with a negative theta. And right here, cosine is an even function, so when I plug a negative, I'm going to get the same answer. So it's going to be r2 plus 2 cosine of theta. So this is going to be a yes here. So it's going to have polar symmetry. But let's go ahead and check the pole. Okay. So is there pole symmetry? So I'm going to replace the r with a negative r. So it's going to be negative r equals 2 plus 2 cosine of theta. And if I divide both sides by a negative 1 here, then I'm going to get r equals a negative 2 minus a 2 cosine of theta. And so this is going to be a naught. So what it's going to be polar axis symmetry. Okay. All right, let's do another one here. All right, so we're first going to start with our pi over 2 symmetry. So with pi over 2, I'm going to replace the r with negative r and the theta with a negative theta. Okay, so when I do that, this is going to be still a negative r, a 1. When I have a negative inside of here, remember sign is odd, so we're going to bring the negative out. So it's going to change that to a positive. So this will be a 4 sine of 4 theta. We divide by negative 1, so we are not going to get, so I'll have negative 1 minus 4 sine of 4 theta. And that's not the same, so this is not pi over 2 symmetry. So what about polar? So for polar, I'm going to replace the theta with a negative. So we'll have r equals, so when I have a negative, I'm going to bring this negative out. So it'll be a plus 4 sine of 4 theta. So this is not polar. And for pole, symmetry, we are going to replace the r with a negative r. Okay, so when I divide by -1 here, I'm going to have a -1 plus a 4 sine of 4 theta. So that's still no. So what are the other ways? Since we got a no for basically every single one of those, what if I plugged in? So let's go back up here to this pi/2 symmetry up here. So remember, the other way is to replace the r and theta with also r and pi minus theta, like that. Okay, so we'll have r 1 minus 4 sine of pi minus theta. Okay, so when I do this, we'll have 4, and this will be, whoops, I need a 4 right there, I'm sorry. So then we'll have sine of 4 pi minus 4 theta. Okay, so then I'll have 1 minus 4, and that's the difference of 2. So this will be sine of 4 pi cosine of 4 pi minus sine of 4 theta cosine of 4 theta. Well, whoops, sorry. 4 theta should be here, and this should be 4 pi. Sorry, get my opposites. Okay, so sine of 4 pi is going to be 0. So this is going to be a 0. Cosine of 4 pi is going to be a 1. Okay, so this is going to be 1 minus 4. So this all turns into 0, so that goes away. And this will be a negative sine of 4 theta. Take your negative out, so this will be 1 plus 4 sine of 4 theta. Okay, so is that the same thing? So no, so still no, right? Alright, so we need to do the same thing with our polar then. So we've got, for this one, we're going to do negative r and theta minus pi. So it'll be a negative r, 1 minus 4 sine of 4 pi minus theta. So same thing, we're going to say 1 minus 4 sine of 4 pi minus theta. So we'll have 1 minus 4, and then we'll use the difference of two angles. So sine of 4 pi, sorry, cosine of 4 theta minus sine of 4 theta cosine of 4 pi. Sine of 4 pi is 0. Cosine of 4 pi is 1. So this will be a negative r, 1 minus 4 negative sine of 4 theta. So this will be a negative r, 1 plus a 4 sine of 4 theta. And then we'll divide by -1. So we'll have negative, and that is not the same. Phew. So no for that one. Alright, so hopefully it's pole by the time we get through here. So for pole, we're going to replace the r theta again with what? R theta plus, or pi plus theta. So we'll have r 1 minus 4 sine of 4 pi plus theta. So we'll have 1 minus 4 sine of 4 theta, 4 pi plus 4 theta. Getting my Greek letters mixed up today. So we'll have 1 minus 4 sine of 4 pi cosine of 4 theta plus sine of 4 theta cosine of 4 pi. Sine of 4 pi is 0, is 1, so this will be 1 minus 4, and you'll just be left with that sine of 4 pi theta, and we'll have 1 minus 4 sine of 4 theta. All right, with all that work, finally, it is going to be pole symmetric. Good. So if you can remember, this, so this is what we need to remember to be able to show that it's going to be symmetrical. Okay, to be able to show that it's got symmetry to it. So I want you to do that homework, and tomorrow we will finish, but we're not going to graph any of these. We're just going to graph our basic ones like we did yesterday. So, all right, I hope you have a great day. If you need anything, let me know.